Every galaxy begins as a whisper, an almost silent drift of ancient gas, folding slowly through darkness, gathering its courage grain by grain. Across the vastness of space, these giants bloom without sound, shaping themselves over billions of years while we, tiny sparks of consciousness, watch from within one of their spiraling arms. Tonight, we step inside that silence. We slow down enough to feel the universe growing around us, gently, patiently, like a breath spreading through still air. Welcome to AstraFlow. Here, science drifts like starlight and curiosity becomes calm. Tonight, let your thoughts slow down, your breathing find its rhythm, and your mind float through wonder. Before we begin, I'd love to know where you're listening from. Are you lying in bed under city lights, or watching the stars from somewhere quiet? Tell me in the comments. It's always peaceful to imagine the AstraFlow community scattered across the world, drifting together through the same sky. And if this calm journey brings you peace, you can gently support AstraFlow by liking this video or subscribing. It helps this little corner of the cosmos keep glowing. Now, let's begin tonight's voyage into the quiet story of how galaxies grow in silence and how the universe builds its giants. What does it mean for something to grow so slowly that no human will ever see its change? A tree shifts over decades, a mountain erodes over ages, but a galaxy is sculpted across billions of years, so gradually that even civilization itself is too brief to catch its breath. And yet they grow, silently, persistently, without pause. So we ask a gentle question tonight. How do we learn from a universe that moves at the pace of eternity? What lessons lie inside structures that change only by the faintest degrees across unimaginable time? Galaxies do not rush and they do not struggle. They expand, they collide, they transform, always in slow motion, always in a rhythm too wide for our senses to hold. In this question of patience, we find a doorway, a chance to lean back into the cosmic timeline and feel our own lives soften, to sense that the universe is never in a hurry, and maybe for a moment, neither do we have to be. Tonight, as you drift deeper into calm, this question will travel with you, quietly, like a companion walking beside you in the dark, not pressing for an answer, simply opening a gentle space in your thoughts where slowness feels natural again. Before a galaxy becomes a shining spiral or a rounded elliptical giant, it begins as something far simpler: clouds, wisps of hydrogen and helium released after the Big Bang, floating freely through a young and cooling universe. They drifted for millions of years, thin as cosmic breath, gathering in places shaped by dark matter, an invisible framework that held the first outlines of the cosmic tapestry. Imagine these early clouds as strands of silk suspended in a silent room. They move softly, drawn by gravity's quiet pull. Slowly they collect into denser regions, folding and layering until something begins to take form. These clouds cool, they collapse, they gently fall inward. And within those dim pockets, the very first stars begin to flicker. Each newborn star sends out light into a universe that had known only darkness. Their glow marks the first strokes of structure, the first hints of what galaxies would one day become. As more clouds gather, the tapestry thickens, gravity weaves patterns, gas swirls into motion, dark matter cradles the growing shapes. Nothing rushes, nothing forces itself. It is growth guided by inevitability, not speed. Tonight, we prepare to walk deeper into this unfolding story. Across billions of years, through the soft motions of gas, light, and gravity. The universe builds its giants with gentleness, and in tracing that gentleness, you may feel your own thoughts settle into their natural, quiet rhythm. In the beginning, the universe held only the simplest ingredients: hydrogen, helium, and a faint trace of lithium. These elements drifted through space like the softest mist, spreading outward after the Big Bang. There were no stars yet, no galaxies, no shapes or patterns, just a vast, cooling expanse where silence was the only companion. And it's in this quiet, almost weightless environment that the seeds of every galaxy took their first breath. Imagine these early gases as long, delicate threads stretching across a cosmic loom. They were so thin that even travelling through them would feel like moving through nothing at all. But gravity, patient and unwavering, began to guide them. Slowly, invisibly, it drew these threads together, letting them settle into faint clumps that would one day become worlds of light. The wisps gathered, but never in haste. Millions of years passed like a single inhalation. Tiny fluctuations, bare ripples in density, grew slowly stronger. A slightly denser region pulled in more gas, which deepened the well, which drew in still more. Growth by accumulation, never by force. The universe was learning how to form complexity, one drifting particle at a time. If you close your eyes now, you might picture those early clouds the way you'd imagine fog rolling across a still lake. Soft, quiet, undisturbed. They were not yet galaxies, but everything galaxies would become lived inside them already. The potential for stars, for structure, for brilliance. And from this clouded beginning, a quiet transformation was preparing to unfold. Long before galaxies took recognizable shape, an unseen architecture was already forming. Dark matter, mysterious, silent, without color or texture, wove itself into sprawling halos across the universe. Though invisible to the eyes and untouched by light, its gravity shaped everything that followed. Every galaxy, no matter how bright or magnificent, grew inside a cradle carved by this unseen mass. You might imagine dark matter as a ghostly framework stretching across the cosmos. We cannot observe it directly, but we can sense its influence in the way galaxies move, the way stars orbit, the way clusters cling together across unimaginable distances. It is structure without form, scaffolding without beams, yet it creates the skeleton upon which the luminous universe is built. As primordial gas drifted through space, it tended to settle into these halos, drawn in by the gravity dark matter provided. This gathering wasn't violent. It was like watching dew gather along the threads of an invisible web. Slowly, gently, the gas followed the contours of the halo, pooling in the center, thickening until the first hints of a galaxy began to appear. This invisible scaffold determined not just where galaxies formed, but how they evolved. The shape of a halo influenced whether a galaxy became a spiral, an elliptical, or something irregular and wild. Even today, the Milky Way rests inside such a structure, moving through space with the support of a silent gravitational companion. There is something soothing in the idea of a hidden structure holding everything together, quietly, without asking for attention. Dark matter reminds us that not all guidance is visible, not all foundations must be seen to be trusted. Gravity is the universe's softest sculptor. It has no voice, no glow, no physical form, yet it works with absolute patience. Over billions of years it gathers drifting clouds of gas, shaping them into spheres, spirals, and stars. Its touch is gentle but persistent, never hurried, never loud. In the story of galaxies, gravity is the quiet hand that guides every step. Imagine billions of hydrogen atoms drifting alone through the early universe. Each one is tiny, nearly weightless, moving freely. But when two atoms float slightly closer, they exert a faint pull on each other. Add a few more, and the pull strengthens. Over time, vast stretches of time, the gas begins to drift inward, coalescing into something larger than the sum of its parts. This slow gathering resembles snowflakes collecting on a quiet winter night. No single moment defines the build-up. No sound announces the change. Yet, hour by hour, a landscape transforms. In the same way, gravity allows clouds to thicken until they become massive enough to collapse into stars, clusters, and eventually galaxies. The universe's great structures are not built in leaps. They're formed through accumulation, patience, and the steady pull toward connection. As galaxies grew, gravity orchestrated every movement, ensuring that matter found companionship, form, and purpose in the vastness. And in its slow pull, there is a reminder for us. Not everything meaningful must arrive quickly. Some of the universe's most extraordinary creations emerge from stillness. As primordial clouds grew thicker, something subtle began to happen within them. Their atoms collided more often, releasing tiny fragments of heat into the surrounding dark. Over millions of years, this gentle cooling allowed the clouds to shrink inward, not in a sudden fall, but in a long, slow curling, like a breath folding back into the chest. The collapse was hidden, almost imperceptible. Imagine standing on a quiet hillside watching mist gather in a valley below. You cannot see the individual droplets moving, but soon the valley thickens, shapes blur, and a soft weight fills the air. In the early universe, the same kind of hush surrounded these forming clouds. They contracted so gradually that even 1,000 lifetimes would not reveal their motion. As the gas condensed, the densest pockets began to glow faintly under increasing pressure. The collapse created knots, tiny regions where matter pooled with remarkable persistence. These knots would become the first nurseries of stars, dim, cold cradles preparing for ignition. Inside each collapsing cloud, physics worked with quiet precision. Gravity pressed inward. Cooling helped gas settle deeper. Pressure built. But everything unfolded at the pace of cosmic meditation, slow, deliberate, and gentle. This hidden collapse was the first step toward creation within galaxies. Before spirals wrapped themselves across the sky, before stars burst into brilliance, before black holes anchored galactic hearts, there was simply a cloud learning how to grow heavy enough to shine. It is comforting to think that even light begins in darkness, waiting patiently for its moment to bloom. Then, inside these darkened clouds, a moment of quiet transformation arrived. As pressure mounted at the centers of the densest knots, temperatures rose to unimaginable heights. Hydrogen atoms, once drifting freely, began to fuse together, and from this fusion came the first light the universe had seen since the afterglow of the Big Bang. The first stars sparked into existence. They were not gentle stars like our sun. They were immense, hundreds of times more massive, burning blue-white and fiercely bright. Yet their births, though spectacular in effect, happened in silence. No sound can travel through the vacuum of space, so their ignition unfolded like lanterns being lit in an endless, soundless night. Imagine floating in darkness for billions of years, and then seeing a point of brilliant light appear, then another and another. The universe's first dawn arrived not all at once, but in scattered bursts, a constellation forming slowly across a canvas billions of light years wide. These first stars transformed everything. They poured ultraviolet light into the darkness. They forged the first heavy elements in their cores, and when they died in colossal supernovae, they seeded the surrounding clouds with carbon, oxygen, and iron, materials that would one day become planets, oceans, and even the breath filling your lungs. But in their beginning, they were simply sparks, flares of brilliance marking the quiet awakening of structure. Galaxies began to take on identity as more stars ignited, clustering, shining, shaping the darkness. The universe had been waiting for light, and now it had found it. With the first stars illuminating the cosmic clouds, something profound shifted. What had been dim gatherings of gas now glowed with scattered points of brilliance. The earliest galaxies learned to shine, not through design or intention, but by the natural unfolding of physics and time. The brilliance did not form patterns instantly. At first, these young galaxies were like shimmering clouds sprinkled with light, irregular and loosely bound. But as more stars ignited, their combined glow shaped the character of each growing galaxy. Light revealed structure, denser regions stood out, shadows softened, and the once invisible boundaries of a galaxy began to feel real. Imagine standing at the edge of a lake at night, watching the first reflections appear as lanterns are lit one by one across the shore. Each new light changes the water slightly, deepening its shimmer, shifting its mood. In the same way, each new star changed the galaxy, pulling more gas inward, fueling more growth, extending the reach of gravity's gentle hand. As radiation streamed outward from these stars, it warmed nearby gas, creating waves of pressure that influenced where new stars could form. Light did not merely illuminate the galaxy, it sculpted it. It seeded patterns, carved cavities, and highlighted the flows of matter drifting through the young structure. The galaxy, still small by cosmic standards, was learning its rhythm: swirl, cluster, brighten, collapse, rebuild. A slow choreography guided by gravity and light, repeated again and again over millions of years. In this calm dance of illumination, galaxies found their identity, not through sudden change, but through steady accumulation of light. As galaxies continued to gather mass, the clouds within them moved in long drifting paths, slow rivers of gas weaving through the newborn star fields. These clouds, shaped by gravity and stirred by early starlight, often found themselves crossing one another's routes, and when they met, they didn't collide with violence. Instead, they drifted together like two soft fog banks merging over a quiet valley. When these vast clouds overlapped, their densities increased. Gas pooled into richer regions where new stars could blossom. The merging was a kind of cosmic choreography, subtle, smooth, and unhurried. Even though the clouds spanned light years, their movements were gentle, unfolding over millions of years in a rhythm the universe set long before galaxies existed. Imagine watching two slow-moving waves on a still lake. They meet, they fold, they ripple into a new shape. No moment is abrupt, yet the landscape changes completely. That is how gas clouds shaped the galaxies that followed. Their merging determined where spiral arms would gather, where clusters would form, and where dark cavities would open like quiet rooms in the galactic structure. Each overlap produced regions of potential, places where new light might someday appear. The cloud dance seeded the next generation of stars, It also introduced motion, swirl, and direction into the forming disk. Over time, these drifting encounters gave galaxies their texture: the cloudy lanes, the shining bridges, the arcs of dust and gas that weave through the cosmic night. There is something graceful in this slow, inevitable merging. It reminds us that creation often happens not in explosive moments, but in soft meetings, gentle convergences, and long, patient dances across time. Within the dense pockets left by merging clouds, groups of stars began to form together, sometimes dozens, sometimes thousands, bound by gravity into shimmering clusters. These clusters became the first lanterns inside the growing galaxy, glowing softly through dust and darkness, illuminating their surroundings like warm lights in a vast and ancient forest. Imagine drifting through space and approaching one of these clusters. The stars, still young and blue-white, shine with an intensity that fills the void with quiet radiance. Some are massive and short-lived, burning fiercely before fading away. Others are smaller, destined to shine steadily for billions of years. Together they create a kind of cosmic hearth, a gathering of flames in the cold. Clusters shape the galaxy not only through their light, but through their gravity. Their combined pull helps sculpt surrounding gas, creating lanes and arcs where new stars could ignite. Over time, many clusters drifted apart, their members scattering across the galactic disk. Others remained tight-knit, preserved as globular clusters that still orbit galaxies today, ancient relics of the early universe. These clusters acted as signposts for the galaxy's evolution. Each one marked a place where the gas had cooled just right, where pressure had risen just enough, where gravity had held just firmly enough to ignite stars in groups rather than isolation. Their glow revealed the galaxy's inner workings, regions of abundance, regions of calm, regions waiting for future creation. There's a comfort in thought hidden inside these clusters. Even stars, those solitary symbols of brilliance, begin their lives in company. They are born together, shine together, and only later drift apart into the wide, open arms of the galaxy. As more stars and gas pooled into the forming galaxy, a new motion began to take shape. Slow at first, then gradually more organized. The galaxy started to rotate, not in a sudden spin, but in a gradual gathering of momentum, like a gentle whirlpool forming in a quiet river. This rotation determined much of what the galaxy would become. As matter circled the galactic center, the spinning motion flattened the structure into a disk. Stars and clouds arranged themselves into sweeping orbits, each following its path with remarkable stability. Over millions of years, the galaxy discovered its rhythm, a pace set not by sound or pulse, but by gravity's steady guidance. Imagine watching a leaf caught in a softly swirling pond. It doesn't rush. It glides, drifting in a wide arc, tracing a pattern the water gently defines. Stars behave similarly in a rotating galaxy. They move in vast, silent loops, each orbit taking hundreds of millions of years. And yet the motion feels serene, almost musical in its consistency. Rotation also introduced order. It separated fast-changing central regions from the calmer outskirts. The disk settled. Lanes of dust began to form. Clouds stretched into elongated threads. This widening spiral of movement became the foundation for the galaxy's future shape. With rotation came harmony. With harmony came structure. And with structure came the beauty of spirals, bars, and disks that many galaxies now display. The galaxy had found its rhythm, a slow cosmic breath expanding outward across time. As the galaxy's rotation grew smoother, something elegant emerged within the disk. Patterns, faint at first, then unmistakable, began to stretch outward from the centre. These patterns curled into sweeping arms, spiralling gracefully through the galactic plane like petals unfolding in slow motion. The spiral arms were not solid structures but waves, regions where gas and stars gently crowded together, creating brightness and form without rigidity. Imagine walking through a field of tall grass on a windy day, where the breeze moves strongest, the blades bend together, forming patterns that drift across the landscape. The grass isn't fixed in place, yet the shape persists. Spiral arms behave the same way. Stars drift in and out of them, but the arms themselves endure, shaped by the subtle push and pull of gravity and rotation. Within these arms, star formation flourished. Clouds compressed as they passed through the denser regions, giving birth to clusters and new generations of light. Young blue stars illuminated the arms, outlining them with brilliance. Regions rich in dust glowed in soft reds and golds, adding texture to the swirling canvas. The galaxy, once a luminous cloud without clear structure, now possessed grace. Spirals brought symmetry and beauty, giving the galaxy a recognizable identity. They marked the beginning of the galaxy's maturity, the moment when its internal rhythm began to express itself visually. There is a quiet poetry in how these arms form, not through force but through flow, not through rigid design but through gentle collective behavior. They remind us that order can arise from motion, and beauty can unfold simply because the universe allows it to. Even in the serenity of a spiral galaxy, moments of brilliant transformation occur. Among the stars born in the spiral arms, some were massive, burning their fuel quickly and ending their lives in powerful supernova explosions. Though silent in the vacuum of space, these events dramatically reshaped the galaxy's internal landscape. Picture a calm forest where a single ancient tree falls. The sound may be lost in the distance, but the forest floor shifts. Light enters where shade once rested. Space opens for new life. In a galaxy, a supernova acts similarly. When a massive star collapses and detonates, it releases an immense wave of energy, sending shock fronts rippling through surrounding gas. These ripples stir the galactic air, compressing some clouds while dispersing others. They trigger fresh waves of star formation, creating new clusters that ignite like embers scattered by a fire. They enrich the interstellar medium with heavy elements, carbon, oxygen, iron, materials essential for planets, oceans, and eventually the chemistry of life. Supernovae are both endings and beginnings. Each explosion marks the completion of a star's long journey, but it also seeds potential across the galaxy. In their wake, dust and gas swirl in delicate filaments, glowing softly as heated particles cool and recombine. Despite their dramatic nature, supernovae do not disrupt the serenity of the galaxy's growth. They act instead as gentle reminders of the universe's cycle, creation, transformation, renewal. Even in the galaxy's vast stillness, change is always whispering through the stars. Deep in the heart of nearly every large galaxy lies a supermassive black hole, a region of space-time where gravity becomes so strong that not even light can escape. Though their reputation often leans toward the dramatic, these central black holes are far more serene than they appear. Most of the time they rest quietly, influencing the galaxy through gravity rather than violence. Imagine a stone lying at the bottom of a pond. It does not thrash or churn the water. Instead, its presence shapes the currents gently, creating a center for movement to organize around. A galactic black hole plays a similar role. Its gravity anchors the core, helping maintain the rotation and stability of the stars orbiting nearby. These giants formed early in the universe, possibly from the collapse of huge gas clouds or the remnants of the first massive stars. Over billions of years, they grew patiently, absorbing drifting gas, merging with other black holes, and occasionally flaring into bright activity when too much matter spiraled into their grasp. But even during those energetic episodes, the black hole acted as an integral part of galactic evolution, regulating how gas cooled and where stars could form. Most of the time, though, the black hole is calm. It sits in the darkness, unseen yet essential. Around it, stars orbit in elegant paths. Gas clouds flow inward and outward, balanced by long-term gravitational tides. Some galaxies even form glowing disks around their central black holes, thin, luminous rings that whisper of motion too slow for us to witness directly. There is comfort in the quiet presence of these cosmic anchors. They remind us that power does not always express itself loudly. Sometimes it simply holds the center, allowing everything around it to move with harmony. Though the supermassive black hole at a galaxy's center often rests in silence, there are moments, long, slow cosmic moments, when the galaxy offers it a gentle feast. Streams of gas drift inward through the galactic disk, nudged by gravity, stirred by passing stars, or reshaped by the movement of spiral arms. These drifting flows are not torrents, but trickles, threads of matter falling toward the core like soft rivers sliding down a mountainside. As gas approaches the black hole, it begins to swirl into an accretion disk, a luminous ring that heats up as matter spirals inward. The closer it drifts, the warmer it glows. Some disks shine so brightly that they outshine every star in their galaxy combined. Others remain dim, glowing faintly like embers hidden beneath ash. Yet even the brightest among them grow and fade slowly, on timescales stretching across tens of millions of years. Imagine sitting near a quiet fireplace. Every so often a small branch collapses inward, sending up a brief spark, just enough to catch your eye, then fading back into warmth. A galaxy feeding its core follows this same rhythm. Sometimes the central black hole brightens into a quasar, visible across billions of light years. Other times it dims, becoming a shadow once more. These feeding events play an essential role in shaping the galaxy. When the black hole brightens, its radiation pushes outward, heating surrounding gas and slowing new star formation. When it rests, gas cools more easily, gathering into clouds that can birth stars. In this way, the core does not dominate the galaxy. It gently regulates it, ensuring a balance between creation and stillness. A galaxy feeding its core is a reminder that even the most powerful forces in the universe work in cycles, with long quiet stretches between bursts of change. No galaxy grows alone. Surrounding nearly every large galaxy are smaller companions, satellite galaxies that drift in wide orbits, bound by gravity like tiny moons circling a vast celestial island. These satellites are diverse. Some are faint smudges of starlight, others are compact clusters of stars, and a few are surprisingly lively, forming stars even as they orbit their massive neighbour. Imagine walking through a quiet landscape at dusk. The horizon glows softly, and in the distance small lanterns move alongside you, sometimes near, sometimes far, but always present. Satellite galaxies behave much the same way. They accompany their parent galaxy, sharing the journey across billions of years. Their presence is more than decorative. Satellites influence the evolution of their host galaxy through gentle gravitational tugs. They can stir the outer disk, stretch spiral arms, or contribute streams of stars that weave into the main galaxy like delicate threads. Occasionally, a satellite spirals inward and merges with its host, adding its stars to the larger structure. These mergers are slow and quiet, happening over hundreds of millions of years, far too gradual for any single moment to feel dramatic. Our own Milky Way has dozens of these companions, including the large and small Magellanic Clouds, two bright satellites that dance nearby like glowing, drifting islands of light. Over time, some will be absorbed, others will remain as loyal companions for ages to come. Satellite galaxies show us that even on cosmic scales, togetherness shapes growth, connection guides transformation, and companionship, silent, distant, yet enduring, can leave marks more meaningful than any sudden event. From time to time, galaxies meet. Not in collisions as we imagine on Earth, with shattering impacts or violent exchanges, but in slow, sweeping embraces that last hundreds of millions of years. When two galaxies drift close enough, their gravitational fields intertwine, pulling stars, gas, and dark matter into a long, deliberate dance. The beginning of a merger is almost imperceptible. A slight tug on the outer stars, a faint stretching of spiral arms. Over time, these effects grow, drawing the galaxies closer together. Their shapes warp into elegant tidal tails, long streams of stars pulled out like trails of glowing dust. The galaxies spiral inward, their centers approaching with patient determination. Imagine two large clouds drifting across the sky. At first, they pass near each other with only a faint blending at the edges, but slowly the shapes merge, forming a single larger mass. Nothing about the motion feels rushed. Everything unfolds at the pace of drifting weather, yet the consequences are profound. Gas flows inward, fueling bursts of star formation. Central black holes may eventually meet, merging into an even larger heart. The final galaxy may look entirely different from either of the original two. Perhaps a smooth elliptical giant, perhaps a warped and glowing remnant still settling into shape. Despite these transformative effects, the process remains quiet. Stars rarely collide, their distances are far too vast. Instead, they change their orbits, drifting into new patterns shaped by the evolving gravitational landscape. In a merger, the universe teaches us that deep change can arise from slow encounters, those gradual, almost unnoticed moments of connection that reshape everything over time. As galaxies evolve, they tend to settle into two distinct personalities. Some become graceful spirals, their arms sweeping outward like luminous wings. Others grow into smooth elliptical shapes, rounded, diffuse, and filled with older stars. These two forms represent different paths through cosmic history, each shaped by the quiet decisions gravity makes over billions of years. Spiral galaxies like our Milky Way thrive on steady, gentle accretion. Gas flows inward, forming new stars generation after generation. Their disks rotate in calm harmony, sustaining the delicate density waves that sculpt their spiraling arms. Spirals are galaxies still in the midst of creation, still gathering gas, still kindling new starlight, still weaving patterns through the cosmic night. Ellipticals tell another story. Many were once spirals, transformed by ancient mergers that smoothed out their structure. When galaxies of similar size meet, their ordered rotation becomes scrambled, replaced by a puffed-up, rounded distribution of stars. Gas is consumed or heated, leaving little material to form new stars. An elliptical galaxy is a place where time has slowed, where creation has quieted, where the glow comes mostly from old, red, long-lived stars. Imagine the difference between a young, flowing river and a deep, still lake. Both hold beauty, both are shaped by their surroundings. One moves with gentle motion, the other rests in quiet depth. Spirals and ellipticals embody these two cosmic moods, motion and stillness, growth and maturity. Neither form is better or brighter. Each is simply a reflection of its journey, the encounters it experienced, the gas it gathered, the mergers it endured. The universe does not rush galaxies into one destiny or the other. It lets them drift into the shapes that naturally arise from their histories. While large galaxies command attention, most of the universe is filled with tiny ones, dwarf galaxies, small clusters of stars and gas that orbit giants or drift quietly through the cosmic web. Though faint and often overlooked, these dwarfs are essential. They were the building blocks from which larger galaxies assembled their mass, the seeds from which cosmic giants sprouted. Dwarf galaxies vary wildly. Some are rich in gas, forming stars slowly but steadily. Others are dim and ancient, holding only the faint embers of stars formed billions of years ago. Many appear irregular, their shapes distorted by nearby giants or by their own uneven gravity. Yet despite their simplicity, dwarfs are incredibly resilient. They survive tidal forces, endure mergers, and preserve some of the oldest stars in the universe. Imagine small villages scattered around a great glowing city. Each village holds its own history, its own quiet traditions, and from time to time some are absorbed into the larger community, enriching it with new stories. Dwarf galaxies behave the same way. As they orbit larger galaxies, some are gently pulled apart, their stars forming luminous streams across the sky. Others merge slowly, contributing their mass and metals to their host. The Milky Way's halo contains dozens of these dwarfs. Some are so faint that we only discovered them recently. They remind us that not all contributions to growth are grand or luminous. Some arrive softly, in small increments that accumulate into greatness. Surrounding every galaxy is a vast, nearly invisible halo of gas, hot, thin, and stretching far beyond the bright disk we normally imagine. This halo acts as a long-term reservoir, storing material that will eventually drift inward to fuel future generations of stars. From this reservoir, delicate streams of cooler gas fall toward the galaxy, like faint rivers descending from mountaintops toward a fertile valley. These streams are slow. Each one may take billions of years to reach the disk. But as they descend, they cool and condense, thickening into filaments that eventually blend with the galaxy's rotating structure. When they arrive, they replenish the gas that star formation consumes, allowing spiral galaxies to continue shining for ages beyond what their internal reserves could support. Imagine watching thin lines of mist drift down a distant hillside at dawn. They move with patience, barely visible unless light catches them just right. Yet they nourish everything below, sustaining life in quiet cycles. The halo's gas streams behave much the same way. Their movement is subtle but essential, feeding galaxies with the raw material necessary for ongoing creation. As these streams merge with the disk, they stir gentle turbulence. New clouds form, Old clouds gain fresh mass. Star formation rekindles in regions that had grown quiet. Over time, the streams help maintain the balance between consumption and renewal, a balance galaxies cannot sustain on their own. Even though they're nearly invisible, these gas streams remind us of something profound. Much of what sustains growth happens beyond our view, in places we seldom look, guided by processes we can sense but not directly see. Inside every galaxy, star formation unfolds in long, gentle cycles. Clouds gather, they cool, they collapse, stars ignite. Then, after millions or billions of years, those same stars release their material back into space, enriching the galaxy with elements that will help the next generation form. Nothing is wasted. Nothing ends without offering something new. Imagine a forest where fallen leaves nourish the soil, preparing the ground for future growth. The forest changes slowly but continuously, each cycle deepening its richness. A galaxy operates in the same quiet rhythm. When old stars swell into red giants, they shed their outer layers like petals drifting away on a soft breeze. These layers become part of the interstellar medium, blending with dust and gas that will someday form new stars. Massive stars end their lives differently, exploding in supernovae that return heavy elements to the galaxy. These explosions may sound dramatic, but in the silence of space they happen without a whisper. Their shock waves ripple outward, gently compressing nearby clouds and encouraging new star formation. In this way, endings seed beginnings. The cycle is never rushed. A single star's life may span billions of years. A cloud may take millions of years to collapse. A galaxy's star formation history unfolds across cosmic epochs. And yet, within this slow rhythm, something profoundly nurturing takes place. The galaxy continually renews itself, passing material from one generation of stars to another. When we look at the night sky, every point of light is part of this ongoing cycle, a moment within an endless sequence of creation, illumination, and return. The universe breathes through its stars. At the dawn of time, the universe contained almost no elements beyond hydrogen and helium. Everything heavier, carbon, nitrogen, oxygen, silicon, iron, had to be forged inside stars. This gradual accumulation of heavier elements is known as metal enrichment, and it is one of the quietest, most essential processes in galactic evolution. When the first stars lived and died, they returned newly forged elements to space. These atoms drifted into clouds mixing with pristine hydrogen gas. As new stars formed, they incorporated these metals into their structure. Over time, each successive generation of stars became slightly richer, slightly more complex, slightly more capable of supporting planets, moons, oceans, even life. Imagine a vast sea into which tiny droplets of colour fall slowly, each droplet spreading, tinting the water shade by shade. At first the sea looks unchanged. Then, after many cycles, the colour deepens. Patterns emerge. What began as something simple becomes layered with depth. That is how galaxies grow chemically richer, drop by drop, star by star. Metal enrichment affects how galaxies shine. Metals allow gas to cool more efficiently, encouraging new star formation. They influence a star's colour and brightness. They determine whether planets can form and whether those planets might sustain oceans or atmospheres. In the Milky Way, the atoms in your body, the iron in your blood, the calcium in your bones, were once inside ancient stars. Some exploded, some gently shed their layers. All contributed to the chemical story of our galaxy. Through this slow enrichment, galaxies evolve not just in shape and size, but in potential. The cosmos becomes more capable of complexity, more capable of life, more capable of the quiet wonders we're still discovering. Although galaxies grow by gathering gas, they also breathe outward. Across millions of years, powerful winds sweep through a galaxy, carrying gas and dust from its interior out into the halo and beyond. These winds arise from supernovae, from clusters of hot young stars, and sometimes from the activity around a central black hole. Yet even at their strongest, they move slowly by cosmic standards, expanding with the patience of drifting smoke. Imagine a campfire on a still night. Smoke rises in long, gentle columns, carrying the memory of the fire into the cool air above. Galactic winds behave much the same way. They lift material from star-forming regions and distribute it through the galaxy's atmosphere. Some of this material eventually falls back like soft rain nourishing the ground. Some escapes entirely, drifting into intergalactic space. Outflows play an important balancing role. Too much gas, and a galaxy forms stars too quickly, burning through its fuel. Too little, and star formation slows to a whisper. Winds regulate this balance, ensuring that the galaxy breathes with sustainable rhythm. These outflows also spread heavy elements outward, enriching the halo with the products of stellar life cycles. Over time, this creates reservoirs of chemically diverse gas that can someday return to the disk, forming new stars with richer compositions. There is a serene elegance in the idea that galaxies exhale. They gather, create, release, and renew, just as living systems do. Their winds are reminders that even structures spanning hundreds of thousands of light years follow rhythms that feel almost organic. As galaxies mature, their shapes settle into gentle patterns, a central bulge surrounded by a broad rotating disk. This geometry isn't imposed suddenly. It emerges from billions of years of slow motion, guided by gravity and the inward drift of gas. Over time, stars find orbits that weave a soft fabric of structure, giving the galaxy a recognizable form that holds steady even as it continues to evolve. Imagine a potter's wheel turning at a quiet, steady pace. Clay spreads outward into a smooth, balanced shape, gently pulled by the hands that guide it. A galactic disk forms in a similar way. Rotation flattens gas into a thin plane, while star formation fills that plane with points of light, arranged not by design, but by the natural flow of matter in motion. Near the center, the bulge takes shape. It is rounder, thicker, filled with older stars that orbit in many directions. This region reflects the galaxy's early turbulence, a remnant of ancient mergers and chaotic beginnings. The disk,